Hello everyone. So in this lecture we'll see the introduction to elastic constants. So this so we'll start from the introduction. Okay. So in the previous chapter we have discussed the axial deformation of a body when it is subjected to a direct tensile or compressive stress. But we have not discussed the laterals or side effects of the pulls or pushes. It has been experimentally found that the axial strain of a body is always followed by an opposite kind of strain in all directions at right angle to it. Thus, in general, there is always a set of the following two types of strains in a body when it is subjected towards the direct stress. First is primary or linear strain, and second is secondary or lateral strain. Okay. So next. So first we'll see the primary or linear strain. So this is the diagram for primary or linear strain first A. Okay. So we have already discussed in Art 2.2 that whenever some external force acts on a body, it undergoes some deformation. Now consider a circular bar subjected to a tensile force as shown in figure. L is equal to length of the bar, D is equal to diameter of the bar, P is equal to tensile force acting on the bar, delta L is equal to increase in the length of the bar as a result of tensile force. The deformation of the bar per unit length in the direction of force, that is delta L upon L, is known as primary or linear strain. So linear strain is when the tensile force is acting on the body and it is just pulling the body by making the thickness or diameter of the bar smaller. Okay, so that is we call the linear strain. Okay, when external force acts on a body undergoes some deformation, that is the length or deformation per unit, the deformation or the length increases of the body. Okay, so there is some increase in the length of the body, that is we call primary strain. Then secondary strain, this is the figure for secondary strain. Okay, so we have already discussed in the last article on the linear deformation of a circular bar of length L and diameter D subjected to a tensile force P. If we actually study the deformation of the bar, we will find that the bar has extended through a length delta L, which will be followed by the decrease of the diameter from D to D minus delta D as shown in figure 6.1b. Similarly, if the bar is subjected to a compressive force, the length of the bar will decrease by delta L, which will be followed by the increase of diameter from D to D plus D. Okay. If it is thus obvious that every direct stress is always accompanied by a strain in its own direction and an opposite kind of strain in every direction at right angles to it. Such a strain is known as secondary or lateral strain. So when secondary strain, when this bar is pulled by tensile force from both the ends, the deformation or the elongation in the length of body, simultaneously there is decrease in the thickness or diameter of the bar. Okay, so when the compression force is acting on the body, the bar gets compressed, whereas the length decreases, but there is increase in the diameter of the body. So this is what we call lateral strain or secondary or lateral strain. So next, Poisson's ratio. It has been experimentally found that if a body is stressed within its elastic limit, the lateral strain bears a constant ratio to the linear strain. Mathematically, it is given by the formula, that is lateral strain upon linear strain is equal to constant. This constant is known as Poisson's ratio and is denoted by 1 upon m or mu. Mathematically, lateral strain is equal to 1 upon m is equal to into epsilon is equal to mu into epsilon. So this is the formula for Poisson's ratio. So the corresponding change in the lateral length may be found out as usual, that is by multiplying the lateral length. Okay, so these are the various Poisson's ratios for different values for different metals: steel, cast iron, copper, brass, aluminum, concrete, and rubber. So this was the introduction of the elastic constant. Thank you.